Very good afternoon to all my dear students. I welcome you all into the Industrial Pharmacy First. So, dear student, while studying the packaging technology for the pharmaceutical products, we said that the packaging that is an integral part of the pharmaceutical technology. But as such, if you see the details of the packaging, it is or it may not be considered as an integral part, but it is the separate department which is responsible for giving various results, right? So while studying the packaging technology, we saw the various aspects. In that, the one of the important aspect, that is the stability aspect, which is associated with the packaging. So what is the ultimate aim in order to have the packaging, in order to offer the stability? The aim is to provide reasonable assurance that the products will remain at an unacceptable acceptable level of fitness, quality throughout the period during which they are in marketplace, that is available for supply to the patient. That means whatever the packaging that we are using, and what is the shelf life of the drug or the product, the product qualities should not get affected. It should not get affected during its storage. It should not get affected after its opening till its consumption by the patient. So that is what is the meaning, and will be benefit for their consumption until the patient use the last unit of the product. Let's say, for example, 2 years will be the expiry period, right? And if the product that is or the product or the packaging should be such that that should offer all the protection to the product, like say protecting the qualities and the properties of the product until it is in its shelf life. But during its shelf life, it is going to be sold and it is going to be opened, and after that the product should meet all these requirements. So this is the period which is there after the opening. So till its expiry date, the product quality should be maintained, or it is expected not to get alter the product qualities till its expiry date. That is what is the meaning, right? So the protocol for stability testing is a prerequisite for starting stability testing and is necessarily a written document that describes the key components of a regulated and well controlled stability study. So there should be a written protocol, there should be a written document. The protocol can depend on whether the drug is new or is already in the market. Now, in order to ensure all these, there is a ICH, that is the International Conference on the Harmonization. So this ICH that will works on the quality guidelines, efficacy, safety, and the multidisciplinary aspects. So ICH that will stands for the harmonization, and ICH it is the organization. It is the organization which is designed, which is developed by the several countries like say the North America, Europe, Pacific, Asia Pacific, Australia, Africa, and the South America. And what is their purpose? Their purpose to have the harmonized policies, harmonized global procedures which is related with that of the production, storage, stability, and all other aspects. So every industry is global and producing here, exporting into the US. Let's say for example what the product is going to be produced in case of India, that is going to be distributed throughout the world. So there is need to have the harmonized procedure, there is need to have the uniform procedure, uniform protocol, uniform steps. So that is decided by the ICH in order to ensure what? In order to ensure the safety, efficacy, stability, and the quality guidelines. So that is the ICH. It is better to have a harmonized guideline for a set of tests. Whatever the test, whatever the assays are there, they should be harmonized. The testing condition is based on inherent stability of the compound, the type of dosage form, and the proposed container closed system. The protocol depends on the type of drug substance or the product, and the protocol should also reflect the regions where the product is supposed to be marketed. Like say, if there is a harmonized ICH guidelines, then in that case only it is globalized and it is uniform. The next stability aspect, that is the compression strength testing. That is how much strength that is going to be beared, that is going to be tolerated by the product, by the packaging. So the package that will behave differently when exposed to the compressive forces. So as you can see here, the specific product that is going to be held and it is subjected to that of the exertion of the compression, exertion of the pressure. So that will causes the measurement of a strength. This one end that is going to be fixed, and from other end the pressure is going to be exerted, and this is the movable head that is responsible for exerting the pressure, and the direction of load that is toward the downward direction, and the speed of testing that is 0.05 per minute. Next, it uses testing capabilities to apply compressive forces to package and the product. So the compressive strength that is going to be tested onto the product as well as onto the package, more specifically onto the package. It provides a compressive report with data on the strength of the package. That is the how much strength that is going to be tolerated or how much strength that package is going to be possessing. Then there is a distribution simulation testing in which the packaging is going to be dropped from a certain height in order to ensure its integrity or how it will protect to that of the product. The packages experiences many different forces during the shipping, distribution, and handling processes. So these distribution process, or it is the product manufacturer's responsibility to evaluate and document the ability of the package to withstand the distribution and storage environment. You might have seen on most of the packaging material, it has been mentioned that do not use hooks or it is fragile, handle with care, right? So that will indicate, and it is the responsibility of the manufacturer to take care of all these things. Not only they should give instructions, but the package should have that much strength in order to protect the product. Package strength testing. So here this is particularly for the pouches kind of the packaging. The package strength testing is conducted to measure and ensure that the components of the package will not separate when specific forces are applied, because there is a air inside, and if it is a kind of say pouch like packaging, then in that case it should bear sufficient mechanical force so that the package should not get teared or should not undergo breaking, so that its qualities that should not get affected. The testing of flexible components such as pouches, seal peel, or burst testing are methods used to prove the package's strength. Package integrity testing, this will particularly uses in order to determine the leakage, like say it is going to be deep into the water, and if there is any kind of opening, so that will leads to the very clear and easy inspection of such leakages. So that is what is the package integrity testing. It uses established tests to test the integrity of a pharmaceutical package. Such tests include dye leak, visual inspection, vacuum leak, and bubble leak testing to inspect the package's integrity capabilities. So, this is what is all about the stability aspects of the packaging. Now, let's study that what is the standard method of ascertaining the quality of a packaging material and the container. So, this particularly covers the quality control aspects associated with the glass material, metal, plastic, etc. So, we are going to be studying the quality control test for the packaging materials like say glass, plastic, metal, and the closures. So, the lecture plan that will move through these particular points. For glass material, again, the glass material that is going to be used as a packaging in case of most of the liquid orals and the parenteral products. So, particularly the tests which are to be performed in order to assure the quality of the glass material, that is the hydrolytic resistant test, powdered glass test, water attack test, arsenic limit test, and the light transmission test. Hydrolytic resistance test, that is in order to determine whether the alkali leached from the surface of a container is within the specified limits or not. The amount of the acid that is necessary to neutralize the released alkali from the surface is estimated, and the leaching of alkali is accelerated using elevated temperature for a specified time. So that means the glass material that is responsible for releasing the alkali into the product, and this can be determined with the help of hydrolytic resistance test, that is the HRT, hydrolytic resistance test. So the endpoint indicator, that is the methyl red, which is going to be used in order to perform the acid base titration. So this test is done in order to detect the type of glass. So what type of container is there and what kind of test that is to be done. So type 1 and type 2 glass containers, that is in order to distinguish from type 3 glass container, the test 1, that is the surface test, is to be performed, because type 1 and type 2, these are highly resistant glasses. Type 1 and type 2 glass containers, whether or where it is necessary to determine whether the high hydrolytic resistance is due to the chemical composition or the surface treatment. So for this, the test 1 and test 2 need to be performed. Now, what kind of number of containers that are to be chosen, that are to be selected? Choosing container numbers per volume, that is capacity of container. Let us say, for example, if it is up to 3 ml capacity of a container, like say ampoules or the syringes, then the number of containers that should be used in order to perform hydrolytic resistance test, that is the 20, and the volume of the test solution to be used for titration, that is 25 ml. If the volume or if the container is 5 or less than that, then in that case the number of container used, that is the 10, and the volume of the test solution to be used for titration ml, that is 50. If the capacity of the container that is within the range of 6 to 30 ml, the number of container that are to be used is 5, and the volume of the test solution to be used for titration that is 50 ml. And if the capacity of the container that is more than 30 ml, then in that case the number of container which are to be used that are 3 in number, with the volume of the test solution that is to be used for titration that is maximum 100 ml. So as this volume of container that will goes on increasing, the number of container that is going on decreasing, but again the volume that is to be tested that will goes on increasing. So there is a quite inverse and direct relationship as far as the number of containers and the volume that is to be used in or with respect to that of the capacity of the container. So what are the test 1 and test 2? So the test 1, that is nothing but the surface glass test. So in this test 1, what is to be done? First, we need to select the container. We need to rinse the container twice with that of the water. Then it is going to be properly washed. Then this container has to be filled with that of the distilled water which is fresh, that is 90%. We need to cover with the aluminum foil. Then it is subjected to the process of autoclaving at 100 degree Celsius to the 120 degree Celsius for 20 minutes. It is going to be maintained at 120 degrees Celsius for 1 hour and at lower temperature for 40 minutes. Then there is need to remove the container. There is a need to cool it. There is a need to titrate it within 1 hour with the specified volume of test solution. There is need to titrate with 0.01 molar hydrochloric acid in order to ensure the end point, which is colorless. The result is not greater than the value stated in the next table. So here this particular table that will shows that after performing the test 1, in respect of these table, the results should come. So based on the capacity of the container corresponding to that of the 90% average overflow of volume, that is per ml, and the volume of 0.01 molar hydrochloric acid per 100 ml of test solution, it should not be more than 1, and type 1 or type 2 glass if it is, for which the maximum volume that is to be used that is 2 ml, and if it is the type 3 glass, the volume that should be 20 ml. So as this will goes on increasing, let us say for example if the capacity of container that is more than 500 ml, then in order to perform the type 1 and type 2 glass test, the volume that should be 0.2 ml, and in case of the type 3 container, the volume that should be 2.2 ml, that is maximum. So in accordance with that of the container capacity, the volume of hydrochloric acid required per 100 ml of test solution for type 1, type 2 and type 3, they will go on differing, they will go on decreasing in this particular order. As far as the test 2 is concerned, it starts with rinsing the container twice with water and with 4% volume solution of HF. Then allow it to stand for 10 minutes. Empty the container, rinse it 5 times with that of the water, and carry out the test similar to the test 1. The next test, that is the PGT. PGT, that is nothing but the powdered glass test. HRT, hydrolytic resistance test. PGT, powdered glass test. So the powdered glass test is to be performed in order to estimate the amount of alkali leach from the powdered glass at the elevated temperatures. So leaching is assessed by acid-base titration with 0.02 normal sulfuric acid using methyl red as an indicator. So the step one, that is the preparation of glass specimen, and the step two, that is the washing the specimen. So the preparation of the glass specimen, that consists of the few containers are rinsed thoroughly with purified water and dried with stream of clean air. Grind the containers in a mortar to a fine powder and pass through sieves number 20 and 50. Step 2, that is the washing the specimen. 10 gram of the above specimen is taken into 250 ml conical flask. Wash it with 30 ml acetone and repeat the washing. Decant the acetone and dried it, after which it is used within 48 hours. So this is the detailed procedure as far as the powdered glass test is concerned. So 10 gram of sample is added with 50 ml of high purity water in 250 ml flask. Place it in autoclave at 121 degrees Celsius plus or minus 2 degrees Celsius for 30 minutes. Cool it under the running water. Decant the solution into another flask. Wash again with 15 ml high purity water and again decant. Titrate immediately with 0.02 normal sulfuric acid using methyl red as an indicator and record the volume. The USP has given this particular acceptance criteria for the powdered glass test. Powdered glass test, that is very, very official in case of the United States of Pharmacopoeia, whereas hydrolytic resistance test, that is official in case of Indian Pharmacopoeia. So based on the type of container, that is type 1, type 2, type 3, the volume of 0.02 normal sulfuric acid, that is per ml, which is required, that is 1.0, 8.5 and the 15.0. Water attack test, that is USP, only for the treated soda lime glass container this test is going to be performed. Water attack test, yes, only for the treated soda lime glass containers, not for the type 1 and type 2, because these are highly resistant. Only the soda lime glass or the general purpose glass or the NP glass, that is undergoing the water attack test. So under the controlled humidity conditions, which neutralize the surface alkali, and glass will become chemically more resistant. So the principle is to detect the leached alkali from the surface of the container. Here we need to rinse or more container with high purity water. Fill each container to 90% of its overflow capacity. Cap all the flasks, autoclave for 60 minutes. Empty the contents and cool the contents in 250 ml conical flask to a volume of 100 ml. Add 5 drops of methyl red indicator. Titrate with 0.02 normal sulfuric acid. Record the volume that is consumed, and the volume should not exceed the limits. That is the acceptable criteria. Then the procedure: rinse thoroughly with high purity water. Fill each container with 90% of its overflow capacity with water. Autoclave at 121 degrees Celsius for 60 minutes. Then it is cooled and the liquid is decanted, which is titrated with 0.02 normal sulfuric acid using methyl red as an indicator. Then the volume of the sulfuric acid consumed is the measure of the amount of alkaline oxides present in the glass containers. And the USP acceptance criteria for the water attack test, that is the type of container, volume of 0.02 normal sulfuric acid per ml. For the type 2, 100 ml or below, 0.7, and for type 2 about 100 ml it is 0.2. Arsenic limit test: inner and outer surfaces are washed 5 times with freshly prepared distilled water. Prepare 50 ml using adequate number of test solution. Pipette out 10 ml of test solution from combined content of ampoule into flask. Add 10 ml of nitric acid HNO3. Evaporate the dryness on water bath. Add the residue in an oven at 130 degrees Celsius for 30 minutes. Cool. Add the hydrazine molybdate reagent to dissolve. Heat under reflux on water bath for 20 minutes. Cool to room temperature. Determine the absorbance of reducing solution at 840 nanometer using hydrazine molybdate reagent as a blank. Then the maximum percentage, that is the light transmission at any wavelength between 290 to 450 nanometer, that is to be observed in order to perform the light transmission test. So the absorbance that is going to be determined. So there is external glass, there is an internal glass. The light is going to be passed, and there is a thermal shock test. This thermal shock test, it will consist of the absorbing the shock, that is the temperature, that is the heat. So in order to perform this, we need to place the samples in upright position in a tray. Then this tray is to be immersed. The tray is immersed into a hot water for a given time and transfer to the cold water bath. Then the temperature of both are closely controlled. We need to examine the container for any kind of cracks or breaks before the and after the test, and the amount of thermal shock a bottle that can withstand, that will depend on its size and design. Small bottle withstand a temperature differential of 60 to 80 degree Celsius. See what this is, particularly you might have seen in case of cold season, winter season. Generally, the glass cups or the glass materials, they will undergo cracking or breaking. This is because of what, they could not able to withstand the high temperature. If there is a cup of glass material, and if we are pouring hot coffee or tea into that one, as the glass material that is highly chilled, and as the uh, drink beverage or the hot beverages like say teas and coffees, these are highly hot, so they will subject to that of the thermal shock, that will causes the cracking and breaking of the uh, glass cups. So that is what is the thermal shock test. And the large bottle, they can withstand up to 30 to 40 degree. A typical test uses 4 to 5 degrees Celsius temperature difference between hot and cold water. The next, that is the leakage test. We need to fill the 10 containers with water. We need to fit with intended closures and keep them inverted at room temperature for 24 hours. Then the test is said to be passed if there is no signs of leakage from any container. Then there is an internal bursting pressure test. So the instrument which is used, that is the American Glass Research Increment Pressure Tester. So in this tester, there is a there is a sequential increase into the pressure, and the pressure at which it will, or the glass material that will goes on bursting. So that is going to be noted. The test bottle is filled with water and placed inside the test chamber. A scaling head that is applied, and the internal pressure automatically that is raised by a series of increments, each of which is held for a set of time. The bottle that can be checked to a pre-selected pressure level, and the test continues until the container that will finally burst. So particularly the pressure at which it will going to burst, that is said to be the pressure bursting test. So today we will stop at this particular point only. So